Yes, sir. Good evening to all the construction professionals who have logged in. Thanks for taking off your time for participating in this webinar series. So today we have a very important topic which is directly related to sites, because most of us have the experience of having concrete mix design done in the laboratory, or maybe doing the trials in a college, wherever it is being tested. But the thing is that what is it that is needed to transform it from a theory to practice is what is today's talk going to be all about. Before I give it to the speaker, let me introduce him. We are happy to have Dr. Jagadish Vengala, who is the head EDC Innovation and Incubation Center, and he is also an associate professor at the Department of Civil Engineering, PVP Siddhartha Institute of Technology, Vijayawada. He completed his PhD from BTU Belgaum and Masters from BMS College of Engineering, Bangalore. He has worked for 4 years in industry, 11 years as scientist in Research Institute at Bangalore, and as head of Department of Civil Engineering at BMS IT, Bangalore for 2 years. He is the recipient of Voice Cast Fellowship, Young Scientist Award by ICI, and Vishwakarma Award by CIDC. He has delivered 130 invited and guest lectures at various national and international forums. He has chaired, co-chaired more than 20 sessions in international and national conferences and published more than 40 research papers in various international and national journals, and he has a rich experience of around 20 years in teaching, industry, and research work. So we are very happy to have you here, sir. Before that, let me also tell you that tomorrow also we are having a webinar on a panel discussion, in fact, tomorrow, which we are having, which would be we would be having 3 panelists who would share their experiences on the various challenges that is faced when concreting is being done at site. So we would be having Dr. Nagendra, Engineer Vishwanath, and we will be having the 3 panelists tomorrow at 10:30 a.m. And we would be looking at concrete from a researcher's perspective, from a practitioner's perspective, and from the testing methodology. So that discussion will happen tomorrow. Just to give you a brief about the webinars that we have been conducting over the past few days. We have conducted webinars on blended cements. What is the relevance of blended cements? We have done a few webinars on concrete mix proportioning, durability of concrete. Then we had a webinar on smart cities, ready mix concrete, sustainability in concrete, and some of the opportunities that is there for the construction sector post-COVID. So we had panel discussion on all this. And apart from that, we also had a few on topics related to civil engineering, like reinforcement detailing, which is a very important aspect, because unless reinforcement detailing is not done the right way, RCC will not work. So we had a webinar on that. And recently, day before yesterday, we had a webinar on how to have an energy efficient building envelope by Dr. Achuri. And so there were webinars on wide array of topics, which is related to civil engineering, not only confined to concrete technology, but all that affects the construction professionals in general. So we had covered them, and I am sure that you would also join in the future webinars which we would be having. Over the next 1 week, we have scheduled a number of webinars on concrete technology, as well as on basically on concrete technology, but then we have some topics on the reasons for structural failure, because it is not only through success stories that we learn, but also from the failure of structures that has happened, and from the experiences of various professionals, we would be learning some of the lessons from their experiences, which would be an eye-opener for all of us. So we have a wide array of speakers from different parts of the country. We had from Kerala, Karnataka, AP, Telangana, Odisha, West Bengal, New Delhi, Mumbai, and we had speakers from academics as well as from industry. So we had a nice blend of professionals from various walks of life. The basic objective was to give different perspectives as far as various problems are concerned, various challenges that we face are concerned, because when you get different perspectives, you get different ideas. And I am sure that each one of us will have some takeaways, some insights from all these webinars. of course, based on these interactions with various project customers, as you all know, Ramco Cements is having 12 different varieties of cement for various types of works, for various concrete works. We have ordinary Portland cement. Within ordinary Portland cement, we have OPC 43, 53, and 43 grade infra, 53 grade infra, so that you get a higher slump retention. And then we have Portland Pozzolana cement, within which we have Ramco Supercrete, Ramco Super Grade, Karthik cement, and then we have the Ramco Superfine. Ramco Supercrete is a cement, PPC cement, which is having a high compressive strength and at the same time low heat of hydration. So that is a cement that we are having, which has been fine-tuned. Then we have cement for precast works, the Ramco Superfast, which is being given to different precast units across the country, and we have got good feedback, and their opinion and the results that they have got is in terms of faster removal of formwork, higher number of blocks per bag, and it has also given them economical way of casting blocks or precast items. So that's the kind of fine-tuning that has been done. So what is more important is that rather than looking at the different varieties of cement, it is very important that you look at the concrete properties. How much of slump, how much of strength is required, and based on the concrete properties, one has to decide the type of cement that is to be used. So that is why we have a questionnaire also to understand the concrete requirements of various project sites and various project customers. So we are looking at this from a very scientific perspective and from a very engineering perspective, so that the customer gets the best as far as concrete is concerned. So that's it, and let me invite once again the speaker, Dr. Jagadish, who has taken off his time from his busy schedule. I'm sure that he would be having a number of online classes as well, but in spite of that, he has taken off time to speak to us. Over to you, Dr. Jagadish sir, for your presentation. Thank you so much.
Thank you for inviting me on behalf of Ramco. And I'm very happy to deliver a talk on this topic, concrete mix design theory to practice. It's coincidence that tomorrow presentation is going to given by my concrete guru, Dr. R.V. Ranganath from BMS College of Engineering, and also my old boss, Dr. R. Nagendra from Stud and Techno Clinic Private Limited. And I was very happy to associate with them in past and even current. With my experience, I'm going to give you next 1 hour some insights on concrete mix design. Yeah, coming to the mix proportioning, my professor used to tell me it's both art and science. It's not just mixing different constituents, it is both art and science, mixed proportioning is. And I would like to play one video why we have to go for mixed design. This is very important. This I have taken near to my house, wherein they are mixing the concrete. This is a general site, what you see near any construction of any building. So, you see here, people are putting whatever amount they are, approximate whatever mix operator is saying. This mix operator put some water and he has gone somewhere and he is just coming back. Meanwhile, this lady is putting coarse aggregate and this boy is putting again the water. And one strange thing I'll tell you here, I would like to mention you. She just put coarse aggregate. Immediately, this boy is turning the mixer and placing the concrete. This is the kind of quality control we expect, or we actually, foresee in many of these sites in small constructions. Because if quality control engineer is not taking care, these are the things that happens. What happens? Because there is no mixed design, they're simply putting it. So you cannot just left to the judgment or guesswork of this particular concrete mixer operator or a contractor who is taking care. So it has to, be in safe hands with the quality control engineer who is having a very good knowledge about it. What happens when you do the volume batching? Simply you place it and you do it. You end up in a lot of complication because any specific variable changed in the concrete, any of the specific variable change, certain desired properties may oppositely affect it. This is what it happens. Yeah. What is our aim in concrete mixed proportioning? You have to optimize different conflicting requirements. You have to satisfy the workability requirement, at the same time strength, at the same time durability, and at the same time cost. And you have to apply whatever sound technical principles governing are there, different mixed proportioning procedures. So all these procedures are just guidelines. Yeah, as I mentioned, volume batching, many of the times people go for 1-4. It's a traditional kind of mixed design. And here, water content is modified to get the workability. But most of the time, actually you have to do based on the mass. Why, I will tell you. A small work done by, very interesting work, difference between volume batching and wave batching. You can see here 20 mm maximum size aggregate, approximately 19 mm aggregate. See, volume batching, if you look, different mixes, 1, 1.5, 3, 1, 2, 4, 1, 3, 6, what we are talking about. Suppose if you convert that into weight equivalents, you can see, the difference in strength between wave batching and volume batching. You always end up in getting wave batching more strength. This is a good example you can see here, wherein all the volume batching mixes, wherein you get the mix binder to aggregate ratio, you get kind of more, and then you end up in particularly wave batching, you get a good result. So that is the importance of wave batching. This is just wanted to give some kind of example. What are the principal factors that governs any concrete mix design? The first is workability. You have to, once you make the concrete, you have to properly transport and place the concrete in position, and you have to maintain the workability till then. You measure the workability using regular slump cone method. And strength of the concrete, that is also one of the principal factor, governing factor in designing the mix. And what type of cement you are using and what is the strength in 28 days is also important. And you know that IS 456 gives you what is the minimum cement content you have to use and maximum water cement ratio you have to use based on the durability considerations. So exposure conditions are very, very important, starting from mild, moderate, severe to very severe and extreme conditions. So IS has given quite a good guidelines. So, but all ingredients, whatever you proportion, you have to go with by weight per unit volume of the concrete. And also aggregate grading, shape, size, and surface texture is also important. These are the principal factors governing in mixed design. What is the objectives of concrete mixed design? One is it has to meet the strength requirements and it has to fulfill the durability requirements, whichever the structure, wherever it is in that particular environment, and it can be mixed, transported, and compacted without any problem. And it should, at the end of the placing, you should have the satisfactory appearance to the mix, and as far as possible it should be economical. So how do you go ahead with the concrete mix design? We all know that. So first, we follow some guidelines. They are based on past experience, based on published data, information obtained from the properties. What we do, we conduct small scale trials in the laboratory and testing, and then we also conduct full scale trials before construction begins at the site. We all know that. And then we will go ahead with the actual, concreting. So this is the, a slide all of you know, very important. The exposure conditions, mild to extreme, and then you have to restrict to maximum water cement ratio to 0.55. As per the exposure condition, you have to go with the grade. It is very, very important to give a lot of importance to exposure condition. Here, I would like to give one small example. If a particular normal weather condition, if a small structure, if some of the elements like columns, beams, if you are going for M20 grade of concrete, say that is mild condition, particularly if it is RCC. So suppose you cannot go for M20 grade of concrete for same weather condition, the footings, because footings comes in the condition, it is buried under the aggressive soil. So you have to consider that as a moderate exposure. So when I was doing, last 20 years back, there was always this confusion among the contractors. We strictly recommend, whatever may be the normal weather, one has to go for, moderate exposure for the footings. So the minimum grade of concrete for it is M25 grade of concrete. So that is why a lot of, importance is given for the exposure condition. Sorry. Yeah. So when you look into this table, so you know that for RCC, cement content starts with 300 kg per cubic meter of concrete to 450 kg per cubic meter of concrete, and maximum water cement ratio for RCC, we start at 0.55, and grade of concrete, now it is changed. It is ordinary, and then standard concrete, and then high standard concrete, because IS 10262 2019 has given different strengths of concrete, and also Indian standard permits you to use the various mineral and chemical admixtures. So very important whenever you are going for chemical admixture, whenever you are going for chemical admixture, you will look into two things. One is either increasing the workability without altering the strength, or increasing the strength without altering the slump. That means sometimes strength may be the requirement, and sometimes slump may be the requirement. So what you have to do, you will go for the water reducing admixture and either plasticizer or super plasticizer. Here you can see in one of the mix, the slump is 75 mm and strength is 51. When you want the increased slump, you've gone for adding the super plasticizer, and you got the required slump without changing the strength. Suppose if a requirement is strength, you have not altered the slump, and then ratio is being reduced, and you got the required strength by incorporating the super plasticizer. So many times you can see this picture wherein here you can see with and without super plasticizer. When the amount of water, when you're adding, you can check it with flow table spread, and with and without super plasticizer, you can see the reduction in the water content through flow table test. And I mentioned IS permits you to use the mineral admixtures. There are different mineral admixtures. We all use it at various sites. And most common are GGBS, fly ash, and microsilica. These are the most common. And the basic reaction, when you add the water to the cement, basic hydration happens and calcium silicate hydrates forms. When you add the supplementary cementitious materials like fly ash or GGBS, what happens? The excess calcium hydroxide again reacts with the supplementary cementitious materials and forms additional CSH gels, which contributes to the which contributes to the more strength, and the concrete will become more denser. And there's the basic hydration process. When you add pozzolas, what happens? It improves the strength. At the same time, it increases the impermeability. And also, when you add pozzolas, it reduces the bleed pockets because additional CSH gels will form, and then you get increased compressive and tensile strengths in concrete. Particularly when you are looking about the aggregates. using in the concrete. Very important. Earlier jaw crush aggregates are flaky and elongated in nature. Nowadays, VSI crushers have come and vertical shaft impact crushers, wherein you get a nice angular cubical shaped aggregates. And also you have to look into the type of aggregate and where you are sourcing. When we were doing the mixed designs, when some of the aggregate, when we procure from Chennai and Tamil Nadu, where we get, we used to get the specific gravity of 3.1, 3.2 sometimes, when regular aggregates are like 2.65, 2.67. So when you don't consider the mixed design, when you don't go for the mixed design, you end up in getting the problems when you go for the volume batching. And it is very important to see that all the aggregates are graded in nature. Most of the time when you source both 20 and 12.5 mm down aggregates, what happens? These fall into single-sized aggregates. So most of the time, to make it graded aggregate, so we have to add in different percentages. Most common is 50-50, or sometimes it depends on the grading, 60-40, 40-60. We adopt at various sites depending upon the aggregate properties. And it is very important whenever we do the mixed design, SSD condition, saturated surface dry condition, we keep and we do the mixed design. But at site, either the aggregates may be air dried or aggregates may be wet. So you have to adopt, moisture corrections, water absorption corrections. If it is air dry, if it is surface wet, you have to, if it is a completely saturated aggregates, you have to apply the corrections for both the cases, moisture correction and water absorption corrections. And this is a very nice experiment. Generally, whenever you go for the lowest void content, there is a simple test. We have the aggregate density. We measure coarse aggregate. So this container, you can take it. You can repeat various sand to gravel ratios, fine aggregate to coarse aggregate ratios, and whichever gives the lowest void, you can adopt same in the mixed design. Yeah, this is what I'm talking about. So the mixed design, the basic concept is to have the more packing density to reduce voids in the mix. So you can use the this particular method to get the lowest void content. So coming to the mixed design, through example, I'm going to give you this some of the insights in mixed design. So concrete mixed proportioning, the new IS code 10262 2019. So some of the highlights are, you can design different mixes. Ordinary concrete, it starts with M10 to M20, and standard grades are given between M25 to M55 grade. And high strength concretes were mentioned in IS 10262, and M60 to M100, and all the sections are divided into general guidelines and ordinary and standard grades of concrete in the second section. High strength concrete is given, and then self-compacting concrete is given in the other section, and the mass concrete is given in the other section. Somebody is saying audio is not clear. I hope, if somebody can tell me if audio is fine or not.
It is clear, sir. It is clear.
Thank you.
It's very clear. Maybe at the attendee's end, he would not be having the required bandwidth.
Okay, sir. Thank you.
We are able to hear you perfectly.
Yeah, sure. Thank you, sir. And continue. So when you go for the mixed design, you look into workability perspective. So IS 456 has given different conditions, different slump requirements. So you can see it is there. We all know that. So mixing also very important. The minimum mixing time should be at least 2 minutes minimum. So people have to follow it. You have seen the first video wherein before placing the concrete, he just added the coarse aggregate and he dumped the concrete and he's going to place the concrete at the site. And very important, one is water cement ratio to compressive strength. We all know the Abraham's law, but if you don't compact properly, you can see the relation between water cement ratio to compressive strength. If it is fully compacted concrete, how the compressive strength, if hand compaction happens, how it is, and vibration, there's a, and there are limitations for the traditional methods. That is why you have to go for the mixed design. So let me get into the example. Through example, I'm going to explain each step. So these are the details. M40 you've taken, OPC 43 grade. It conforms to IS 269. Fly ash is taken as admixture, mineral admixture, 20 mm. And minimum cement requirements, these are the stipulated requirements given. Maximum water cement ratio is 0.45 because the condition is severe exposure condition. Workability requirement is 120 mm, that is slump, and you have to pump the concrete. And degree of supervision is good, and aggregate is crushed angular. And maximum cement content, we all know that IS limits maximum cement content only, not cementitious content. Cement content to 450 kg per cubic meter. And cement, some of the properties, test data is cement is OPC 43, figure out is 3.15. Fly ash is conforming to the IS 38.2 requirement. Specific gravity is around 2.2. Chemical admixtures, plus size is used. And these are some of the properties of the coarse and fine aggregate. 2.7 is coarse aggregate specific gravity, fine aggregate is 2.65, and water absorption in fine aggregate is 0.5 and 1%. Moisture content, it is nil. So you always, so this is the single graded aggregate. So whatever aggregate is there, 20 and 12.5, this is when we see. Okay, so this is the cumulative percentage of passing of both 20 and 12.5 after 50-50 ratio. So this is satisfying the graded requirement of IS 383. So what you have to do is you have to blend both 20 and 12.5 to suit the graded requirements. And fine aggregate is conforming to zone 2. So there is a little change in target strength formula when compared with the old code. So here they have given FCK plus 1.65 into S, that is the normal. And then they've also given FCK plus X. So this X factor they have given based on the grade of concrete, or otherwise you can take the standard deviation. So there are two types of formulas they've given. So whichever higher you have to adopt. So in the case of X, that is FCK plus X. So they've given grade of, for each grade of concrete. This is ordinary, this is standard concrete, and then, so you can see 5, 5.5, 6.5, and M65 and above, you have to adopt 8 as X. And for the standard deviation, you can see from 3.5 to 6, here, we actually RCC, we started M20, so 4, and then 5, and then M65 to M80, it is 6. So let us go step by step. So first thing, standard deviation we have taken as 5 because it is M40 grade of concrete, and 40 plus 1.65 into 5, that is the target strength, 48.25 you get. So next step is selection of water cement ratio. So earlier IS 10262, there is no mention about the strength to, so this is a new edition wherein this is the chart to free water cement ratio to 28 days of compressive strength depending upon the type of cement. So these three curves will be given 33, 43 and 53 grade cements. So we are using OPC 43 grade cement. So we have to go for the curve 2, and wherein you can select for 48.3 the water cement ratio for curve 2 is 0.36. So you have to add up, yeah, 0.36 is fine. You have to add up 0.36. And when you look into the exposure condition, for the exposure condition, the maximum water cement ratio is 0.45 as per durability requirement. So 0.36 is less than the 0.45. So hence it is okay. You can go with the required selected water cement ratio. Yeah, this is what I'm again wanted to bring to your notice. So here M40, you have to see the exposure condition, even the grade of concrete is M40. So severe condition, the maximum free water cement ratio is 0.45. So I wanted to mention simply to give you some kind of a refresh about the exposure condition, severe. So the structure is either exposed to severe rain because it is severe, and then or otherwise it is completely immersed in seawater, or it is simply in coastal environment like in Chennai, Mangalore, or Visakhapatnam, or so. So next step is selection of water content. You have to select based on the water content table. For 20 mm, it is 186. You can see here, 20 mm 186 when aggregate nominal maximum size aggregate is less. That is, if it is 10 mm, the water content requirement is more because you have a more surface area in coarse aggregates. If the 40 mm, the maximum coarse aggregate, the surface area will become less. You need less water. So 186 we have taken because maximum coarse aggregate size is 20 mm. So slump requirement again. Slump requirement is like 25 to 50 mm slump. This is given. What is this? This 186 liters. So for every 25 mm slump, you have to go for additional 3% of what 3% of water. So in case of 120 mm slump, you can see you can make that correction. So and also it is a pumpable. Anyway, pumpable requirement, you have to reduce coarse aggregate 10% in case of coarse aggregate. Anyway, I'm going to come to that in later stage. So as far as water is concerned, you have to, because the slump is 120, you have to additionally add 3% for every 25 mm. So once you get the water content, then water content is reduced depending upon the superplasticizer addition. So the percentage of superplasticizer dosage is mentioned even in the code, maximum dosage. And also the optimum dosage you can find using the marsh cone test. Many times the compatibility between the coarse aggregate, cement and superplasticizer is achieved by marsh cone test. I'm going to give you that. So this is the marsh cone we generally use. So this is the where what you do, you prepare a 500 ml of paste, and then you pass through the marsh cone, and then you measure the time taken, flow through the bottom aperture. Then you draw the graph between flow time versus superplasticizer to cement dosage. So typically the curve will be like this, and then where there is a saturation, you can see here, these are some of the percentage of admixture dosage. So we start with 0.1, wherein the flow time is 17 seconds, and 15.2, 0.3 is 11.77. After that, there is not much change. So this is 0.3% is the optimum dosage based on the marsh cone test. So superplasticizer dosage and compatibility between cement and superplasticizer, we can taken from the marsh cone test. Yeah. Coming back to the, so once you add the required superplasticizer dosage based on the trials, water content you have to, you can, so this was achieved a water content reduction of 23%. So the rest is 77% of the water is 155 kgs or liters of the water. So suppose if you have a different kind of aggregates in terms of, suppose you have a rounded aggregates, coarse aggregate, then you have to reduce the water content to 25 kgs. And if it is a subangular aggregate, you have to reduce 10 kgs. So you have to adopt depending upon the material property. So many times what happens, once the source of material changes, people follow the same mix design, whatever is given from the lab. So once it is, you have to make corrections and you have to fine tune the mix design, conduct a small trial at the site, and then go ahead with the trial. And then once you got the water cement ratio and then water content, water by cement is equal to 0.36, you get the cement content. So here cement content is 431 kgs. And severe condition, that again durability requirement, when you see the table, for severe condition, the minimum cement content is 320 kgs. And so it is 430 is much higher than the 320 kgs, hence durability consideration is satisfied. But one thing you need to keep in mind, if the coarse aggregate size changes, suppose if you are going for 10 mm down, 12 mm down, then you have to take minimum cement content 320 plus 40, that means 360 kgs as the minimum cement content requirement for the 10 mm down size aggregate for severe condition for the mix. That means the minimum cement content you have to add up. Anyway, maximum cement content, we all know that it is 450 kg per cubic meter cement content alone. So you should not go beyond more than that, because once you go beyond it, there is a risk of cracking. Get the cementitious content, then you have to proportion the mix for the fly ash. How do you decide percentage? You have to decide based on the project, because whatever you have agreed with the contractor and then client or the third party. And in certain situations, you have to increase the cementitious materials based on the experience. So you have to adopt based on any experience and trial or based on the project. But anyway, high strength concrete, the limits are given now in IS 1026 to 2019. I will show you what are the limits. So it's a simple example. Suppose 10% increase you have to do. Already 431 is your cementitious material into 10% increase you have to, then it is 474. Then what is the water content? 155 kg per cubic meter. So how much is your water cement ratio? 0.327. Okay. So once you get that, adopt fly ash for this particular mix for the 30%. So 474 into 30%, then you get the 142 kgs as the fly ash, and you deduct 142 kgs from the cementitious content, and then you get the fly ash. So cement is 322 and your fly ash is 142. So next is, once you got your water, cement, and then fly ash, you have to go for the coarse aggregate proportions. You know that for zone 1, 20 mm aggregate, it is 0.6. And then when zone increases, that means the fine aggregate zone increases, your coarse aggregate volume, increases. So here we are going for, because it is a 20 mm downsize and zone 2 sign, water cement ratio, for water cement ratio 0.55, you can see it is 0.62. That's a table. And our present case, water cement ratio is 0.327. So you have to adopt corrections. It is very simple. If water cement ratio, if you are changing for every 0.05 change, that means increase, you have to reduce 0.01 volume. If you are reducing water from 0.5 to below, that means here in this case is 0.327. So every 0.05 decrease, you have to increase the volume of coarse aggregate by 0.01. So here 0.327, it is like you get 0.62 this is for 0.5, right? So additionally, you have to add it because water cement ratio is reduced. So 0.03, so the total water cement ratio, volume of coarse aggregate ratio, what you get is 0.64. So in this case, again, this is a pumpable mix. So for pumpable mix, you have to reduce the coarse aggregate volume by 10% because you need more paste to push the aggregates because while pumping. So that is the reason we have to reduce the 10%. So volume of coarse aggregate is from the 0.654 into 90%. That means 10% you are reducing. Finally, your volume of coarse aggregate is 0.59. So if you deduct from total volume, it's 1 minus 0.59, it is 0.41. So you know the basic calculation. So you have to take volume of concrete, 1 cubic meter you are doing it, and mass of cement, what you got is 332 divided by specific gravity into 1 by 1000, you get the volume of cement. And specific gravity of fly ash in this case is 2.2, 142 is your fly ash, and then into 1 by 1000 you get the volume of fly ash. And water, 155, you get the water volume. And then you also have to calculate the volume of chemical admixture. Here in this case, 1% by mass of cementitious material we are using. So specific gravity of superplasticizer is 1.145. So you get 4.74 liters per cubic meter. You get the volume. And then you have to deduct from the all-in volume. That means, so here in this case, we have got the air content in IS 106 2019. So for 20 mm, so now the air content you have to take is 1%. So if it is 10 mm aggregate, 0.5. Here our case it is 1% you have to. So that means 1 minus 0.01 minus rest of the cases. So you get the volume of all in aggregates. That means you have deducted the cement, void, fly ash, and then water, and then superplasticizer. So you get the volume of all in aggregates. When you multiply with the specific gravity and then the volume of coarse aggregate, you get the mass of coarse aggregate, and then you get the fine aggregate when you multiply with the remaining fine aggregate. So once you get the mixes, so these are the final mixes, what you got, cement, fly ash, water, fine aggregate, coarse aggregate. So this is for the saturated surface dry conditions. So if your moisture, if you are at site, if you have a moisture or water absorption property, you have to adapt that by checking the properties of aggregates or materials. So once you get the first trial, you have to carry out number of trials and check the required workability and strength at different ages and durability tests. For particularly high strength concrete, nowadays they're referring the durability tests also for tall structures. And here you can see two more. You have to conduct number of trials with plus or minus 10% variation if you don't get the required strength. Anyway, some of the points I would like to give you in case of the high strength concrete, wherein you can see for nominal maximum size of aggregate, the volume of aggregate will be changing for particularly high strength concrete. So you can see, and similarly. For high strength concrete, the water cementitious material ratio also is given in the code book. Now, for example, for 70 MPa, if it is a 20 mm down, so water cementitious material you can adopt is 0.33. So this is the recommended water cement ratio given in the new code for high strength concrete. Even the water content, maximum water content is also given based on the maximum size of the aggregates. So the 20 mm it is remain 186 and 12.5 they're given 195 and 10 mm down it is 200. So a little bit change when compared with it because their water content in IS 456 is given 40 and 10 and 20. But when you are going for the high strength concrete, either you go with the 12, 20, 12.5 or 10, then these are the maximum water content limits that are given. And air content also considerably reduced for high strength concrete. 20 you have to adopt 0.5. That means the least voids you have to go for, particularly high strength concrete. In normal concrete, you have seen that case is like 1%, but here it is 0.5%. And also, these are the recommended dosages, mineral admixture dosages that are given for high strength mixes in IS 262. You can say fly ash can be adopted between 15 to 30. Earlier, for Portland Pozzolana cement, they've given, while for making the cement, the blend can be up to 35% that is given. So now, recommended dosages in direct addition of fly ash is being given here between 15 to 30%. GGBS can be go up to 50%, that is between 25 to 50%. But in cement, Portland slag cements, generally they go up to 60, 65% of replacement. And metacolin, anyway, this is a fine powder, you have to use very small quantities. So between 5 to 15, and silica fume is also 5 to 10% that is given for the high strength concretes. Yeah. Before, I wanted to also mention, because we have worked with my guide, we worked a lot of mixes, self-compacting concrete mixes over a period of time. You can here, volume fractions is very, very important in mix design of self-compacting concrete. With a small example, I would like to end this presentation. These are the mixes we have considered from various parts of the world. These are the cement and filler contents. And then these are the fine aggregate and coarse aggregate proportions. These are the maximum size of aggregates. Okay. What we did, we calculated the volume fractions and much amount of volume paste is present in each of the mixes. So you know that self-compacting concrete, you require higher cementitious content between 450 to 600 kg per cubic meters, and these mixes either the coarse aggregate and fine aggregate contents are equal, or sometimes coarse aggregate content is lower than the fine aggregate content, because you need to keep the coarse aggregate in suspension, and this concrete, unless like vertical slump, you measure the horizontal spread. So when you look into these mixes we have considered from various parts of the world, you can see the volume of paste varies between 0.35 to 0.41. In normal concrete, you might have seen the volume of paste comes around 0.21, around 21% to 23%, so on. But here in this case of self-compacting concrete, the mixes, the volume of paste varies between 0.35 to 0.41. So the mean is 0.38. And in case of Indian mixes, those are from all other parts of the world. But when you take the mixes from the Indian scenario, you can see the paste content, volume of paste varies between 0.37 to 0.46. Why? Because in Indian scenario, you need more volume of paste because of the the consistency of coarse aggregate grading is a problem, and we get more flaky and elongated particles in the mix. So that is why you require more paste volume due to that. And also, if you want to avoid the VMA, you have to go for the higher paste. So when you see the summary of these results, as I mentioned, so you require almost 40% of paste, particularly for SCC mixes. And volume fraction of fine aggregate is almost equal to the coarse aggregate. But here you take a mixed design of normal concrete, you suppose typical mixed design, if you take approximately 700 to 800 of fine aggregate, and then coarse aggregate is almost like 1100 to 1000 to 150, 1200 you get. So that means you get more. But in case of SCC, you have the equal or lesser aggregates. But at sites, you must go ahead whenever there is a change in content, wherein you have to conduct all these trials at site laboratories, and cement particularly, these are the stands you go ahead, these are the tests you do it, and coarse aggregate, these are the tests you have to conduct. Wherein change of source, if there is a change of source, again you have to conduct and fine tune your mix design. And it is very important to conduct tests for both water and admixture, because you don't want to take risk of incorporating more of sulfates or chlorides. So you have to check as per Indian standards, and you have to go ahead with the mixed. So this is what I wanted to present with you. Thank you, Ramco, for giving me this opportunity. Now I'll maybe some of the points I thought which are important I have given, because it is only 1 hour duration. I wanted to give you a kind of why mix design is required and how you go about the mix design with the new code, and then some of the compatibility, why Marshcone is Marshcone test, and these things I have mentioned during my lecture. Okay, over to Anil, sir.
Thank you so much, sir. It was a very interesting presentation. In fact, one of the points that you had mentioned was very apt and relevant. In fact, regarding exposure conditions, even if the structure is in mild exposure conditions, when we go for foundation, we need to adopt a minimum grade of concrete of M25, which normally is missed by many of the professionals. That's a very important point, because we actually classify the structure only at mild condition, but what about those which is buried under soil? Even though it is non-aggressive, we have to go for a minimum grade of M25. That is a very valid point that you have made.
Yes.
Because we tend to miss that many a times.
Yeah. So one presenter, he was asking what is the maximum cement content for high strength concrete. Maximum cement content is limited to 450 kg. However, when you are going for high strength, precious content can go up to 550, 500. In case of self-compacting concrete, they go up to 600. But you have to limit the cement content to 450. As long as it satisfies the durability requirements, as long as it satisfies the workability requirements, as long as it satisfies the strength requirements. So all these codes gives only guidelines. In IS 10262, they clearly mentions these are the guidelines to come out with a particular mixed proportion. So it is again between the client and contractor and third-party person to decide like which concrete, which type of concrete and these things to adopt for the particular structure. Yes, sir.
Very nice point, because many of them are confused. Yeah, sir, because you have, based on our interaction with customers also, customers tend to think that more cement it is added, the quality of the concrete will be much more. And sometimes they tend to cross that 450 kg per cubic meter, which can lead to, as you rightly said, lead to shrinkage cracks and all that. So when maximum cement content is specified. And another very important point which you had mentioned in your presentation, and which we also seen at sites, is that whenever they adopt this volume batching of 1:2:4, and when it is converted to actual this thing, we tend to see that sometimes the cement content is more, or the aggregate, sometimes they miss that aggregate quantity in yes, practical sites, if suppose nobody is monitoring it.
That's why I've showed you some case study. Directly if you adopt 1:4, what happens when you convert into weight, and then how the strength variation between. So I thought it should be given. And somebody was asking about the incorporation of a recycled aggregate. It is very important to know that whenever you are incorporating recycled aggregates, because the aggregate particles contains a lot of paste stick around it, so you need to consider the water absorption properties, and you have to consider, and there are a lot of guidelines now, proven literature is there, and people are using it in many of the sites for different purposes.
Because recycled aggregate has to be used with caution. Yeah, water absorption and all.
Yes, there are different methods. Yes.
One of the questions that is being asked again, relating to the guidelines only. There are so many codal provisions, codes IS, BS, ACI, method of mixed design, and all that. So one of the attendees want to find out which is the best method for common usage in mixed design. Is it the IS code? Is it the BS code? Or is it ACI code?
Yeah, it's very interesting. The thing is, as long as I'm keep on saying, as long as even your workability satisfies the strength and considering the durability requirements, a particular mix is giving economical mix. So whether you follow IS, ACI, BS methods, any method, these are all only guidelines. You can go ahead with any kind of method as long as you get a right mix. And there is a lot of literature comparing all these methods, and then a lot of mixes has been developed and shown the comparison. One can go through the literature, but you cannot say like you follow that. But as we are for structures in India, so we have to follow the Indian standard guidelines, because these are time tested and then formulated into guidelines. Yes, sir.
Very rightly put in, because because what we have done is that we also used to do this mixed design at our research center at Ramco Research Development Center. What we have seen is that when we tend to take the aggregates from the site, those sample aggregate, you get a correct representation of what kind of proportion has to be used to get the required strength and workability. I think that is very important, which again you covered in your presentation, relating to the quality and aggregate grading of aggregates, both fine as well as coarse aggregate, which sometimes most of the sites, I don't think so they go in for any kind of sieve analysis. Sieves are hardly present in most of the sites, so the grading of aggregate is not given much importance to, wherein you can have a lot of economy as far as the concrete goes, if you are going in for
many of the source point, if you go for a crusher, many a times the crusher sieves, maybe sometimes those are not good, so you get a oversized aggregates during the sieving, so you don't know. So that is why you have to sieve it, and then you have to make sure that you have the right graded aggregate in your concrete mix.
One more question that is being asked is very interesting. The maximum quantity of cement may be necessary for high strength concrete, more than M100. What is your view on that?
Sir, people are producing, I will tell you one example with 430, and then with 150 kgs of fly ash, we have produced 100 MPa strength concrete, SCC, in 2000, way back in 2000. So this is for your information. So when you are looking for the durability point of view, strength point of view, you can add admixtures in judiciously. And strength requirement, when you're adding particularly fly ash, so you have to look for long-term strength. So after 1 year, after 9 months, so on. So it is, as long as you have the right mix, the required strength. So obviously you will even get with 400 cement and with a tertiary blend of silica fume, GGBS or fly ash. So a lot of literature is available. You can add to it, sir, Anil, sir.
No, sir, you had mentioned even in IS 10262, the latest amendment, even for high strength concrete, they have recommended 15 to 30% of fly ash can be used even for high strength concrete.
Correct.
That is a very important point. And even for slag, also 25 to 50%.
Even GGBS also.
GGBS also 25 to 50%, and silica fume 5 to 10%. I think those are very important guidelines even for high strength concrete also. So one need not worry, even if it is M100 also, as you rightly pointed out, with the usage of cementitious material, we can obtain it. So what is very important is water to cementitious ratio, as you rightly mentioned in your presentation, rather than going in for water to cement content, water to cementitious ratio. And many places they have obtained high strength concrete with the usage of both chemical and mineral admixtures.
Compatibility must be assured between cement and chemical admixture. and starting from the lab trials to this thing. And there are well proven methods wherein marsh cone test can be used to get the optimum dosage, and then you can limit the the dosage of admixture also.
As you rightly pointed out, apart from the trials in laboratory, trials has to be done even at the batching plant also. Before we go in for a full-fledged mixed design, because in one of the slides you had shown, at site the trials also has to be conducted as part of the mixed design process itself.
Correct, sir. So somebody was asking what should be the cement content if it is exceeded maximum limit for normal concrete. So you have to restrict to 450. That's it. And then you have to redesign the mix.
Yeah, that's true. Each trial strength of the concrete may vary depending on the weather conditions, workability, strength. I don't know what he meant by that. Is trial strength of there is nothing called trial strength of concrete, I believe. There is the target compressive strength is there.
So somebody was mentioning the aggregate surface drying conditions are not possible in rainy season, but still if you have to construct a structure, then what measures one can take? So you have to measure what is the moisture content in aggregate, and then you have to deduct that water from the actual mix, and then calculate. While adding the water, you have to reduce the water content. So there is a moisture content and water absorption corrections you have to adopt, and you have to go ahead with the trial mix.
That's very important during monsoon season. Now that the monsoon is setting in, I think they need to consider that. Otherwise, this we have already covered. I think most of the questions we have covered, sir. Even relating to SEC, already mentioned in your presentation, a host of mixed proportions you have given with reference to the paste content itself, which is very interesting. Because in the Indian context itself, the paste content has to be higher because of the inconsistency in aggregate.
Aggregate, and also if you wanted to avoid VMA, because usually VMA, take care of the sensitivity of the grading of the aggregates. Suppose if there is a aggregate chain, VMA take care of the mix, but usually we add more paste in case of the Indian condition.
So that was a very interesting presentation, sir. I think we have almost covered all the questions. Only one more last question. One student wants to ask about the combustible nature of concrete.
Combustible nature of concrete, yes. Fire resistance, yeah. Neville book one go through, up to 250 degrees centigrade, beyond 250 degrees centigrade, the concrete start, reacting to it, and then it fails. If it is more than 300, the concrete slowly disintegrates. You can see the beautiful Neville book. It is given properly, and a lot of research has been conducted on fire resistance of concrete also from various researchers. Yes.
Because of course concrete has a lot of properties, as you rightly mentioned. Fire resistance property is there, abrasion resistance property is there, and whichever property you want to check, we need to look at that, and that is why ultimately we do the mixed design and all that, to look at what all properties do we need from concrete.
Yeah, at the end, I wanted to thank Ramco Cements for giving me the opportunity, and all the participants. I want you to join for tomorrow's session also, because my guru Dr. R.V. Ranganath is there, my old boss Dr. R. Nagendra is there. You can ask more questions, and then they would love to answers. Maybe I will also join tomorrow's session. Thank you, sir.
Thank you so much, sir, Dr. Jagadish, for having joined us. And also, tomorrow, as you rightly said, we can have a panel discussion. We would be having a panel discussion between Dr. Ranganath, Dr. Nagendra, as well as Mr. Vishwanath, from the practitioner, from the researcher, as well as from the testing methodology. And then I think through that discussion, we will get more points as well. And in fact, today's presentation was very good because you took the mixed design from a different perspective itself, which was very beneficial from the professionals' point of view. And I am sure that most of the construction professionals who have logged in would be able to implement this at site, and also to look at those minor errors that might occur, in terms of how to adjust the water content, in terms of, especially the SSD condition of aggregates, saturated surface dry, which was a very important point that you had mentioned. And when we are adding fly ash, what is the kind of adjustment that we need to do in water cement ratio, which is also incorporated in IS 10262. I think many of them, I do not know how many of them would be aware of the amendments that you rightly showed in 2019, the amendments that has been made, and they have incorporated the high strength concrete. And I am sure that professionals would once again go through those amendments and they will get more ideas. Thank you so much for having given us so much insights on the mixed design from a very practical perspective. And as rightly pointed out by you, it's a challenge covering all aspects of mixed design within 1 hour. But still, you covered most of the critical aspects. And thank you so much for that. And we wish you all the best. And we thank all the professionals for having logged in and spent your time with us. Thanks for patiently listening to us. And thanks for the Ramco team, the host, as well as the IT team for having ensured that this webinar went on very well. Thank you so much, sir. And thank you all the professionals for having joined us. All the best. Thank you, sir. Thank you.